Previously, we saw there are two names given to BGP. Based on where you enable it, the name varies. When we enable BGP between autonomous system, we call it as external BGP, eBGP. The other, internal BGP, within the autonomous system. But within the autonomous system, we already have a protocol, Ospf or ISIS or EIGRP. Well, then why do I need BGP? This is very important point. When I already run Ospf inside my organization, why I need to run BGP, iBGP? See, our Ospf or any inside protocol is working only for our network, inside networks, not for the networks coming from outside. We need this BGP to work for only the outside network. The network that are learned through BGP will be handled by BGP. Only then you can have those attributes and so on that comes as an advantage with BGP. That is what this page explains. From here only we need to start. You see, when you don't have, let's assume there is no BGP. No BGP, no BGP. Let's say we don't have this iBGP also. We don't have. So we got only eBGP. Assume we got only eBGP. So the routes of F is 1111. The routes of A is 7.7.7.7. Now, the 7777 will come here. Likewise, 1111 will come here. But in order to ping 111 from here, this router needs to have route to reach 11111. It needs the route now, otherwise how it will route? Likewise, F needs to know about 7777. This needs to be distributed by the middle autonomous system, the transit autonomous system. This is transit, you see. The source and destination doesn't belong to this middle autonomous system. But still, the middle autonomous system needs to support this communication to happen. The middle autonomous system, what it has to do, it has to take this 1111, give it to this router, so that this router will give it here. Likewise, the middle autonomous system need to take 7777, give it to this router, so that this will give here. Yep. So to do that, we need iBGP. To do that, what we are going to do is we are going to run BGP even between the router that are in same autonomous system, like this. So BGP relationship is not only here and here. Previously we learned that IBGP do not have to be directly connected. Look at this point. Do not have to be directly connected. Internal BGP. So you see B and E to form IBGP, they do not have to be directly connected. It is okay if there is no BGP on D router and C router. No BGP. Still you can form neighbor. It is possible for us to have neighborship. How is it possible? I'll explain how. B and E are already pinging each other with the help of OSPF. By using that reachability, BGP can now negotiate and form neighbor with B, and B can form neighbor with E, because they are already reachable. So after forming neighbor, when the external route comes to BGP via eBGP, without changing any attribute, the updates will be delivered to IBGP, and IBGP will deliver to this eBGP. You see, the purpose of BGP within the autonomous system is to simply distribute the external routes from the right hand side autonomous system to the left hand side autonomous system.
Sir, this is because of there is a one rule called that routes learning from the eBGP.
No, wait. No, you're confusing yourself. Don't bring those things now here. It is next. It's coming later. It is next slide. So you have listened to this same topic earlier. I can understand it. Don't bring that here. Don't bring that here. This is no way related to what I have said.
Okay.
So listen carefully. I am trying to explain you why the BGP is supposed to be between the borders. B very clearly say border gateway protocol. Why that BGP need to be between the routers within, not between borders, within the autonomous system. I'm trying to explain you why I need BGP within the autonomous system when it's supposed to be only on between the border routers. The reason is I want the external route which is learned from the other autonomous system to be carried to the other end of my autonomous system with the same original nature, with the attributes for each destination. But there is another way, no? Redistribution. If you don't want IBGP, what I can do is I can redistribute. If I don't want IBGP, the route that came from eBGP neighbor, I can redistribute to OSPF. Now OSPF, earlier it was only handling the internal network. Now it has also got the external network from BGP. So now when you redistribute from OSPF back to BGP, not only router F routes are going to A, even our internal networks will go to A. That is the reason why Redistributing BGP into IGP, for example OSPF, redistributing into OSPF is not recommended. Why? You are mixing both external and internal networks. We should not mix internal network to network and external network. Not good. Why? If you mix here, taking BGP route, giving to OSPF, and all the internal networks of OSPF mixed with BGP, and when you redistribute back from OSPF to BGP, what happens? Will there be any attributes? No attributes, because OSPF don't understand any attributes. So when you redistribute from BGP to OSPF, all the attributes lost. Not only that, our inside networks are now going to the other autonomous system via BGP, which we may not like all of the time. See, your aim is to just forward the update sent by F to A. But when you redistribute, you lost the attributes that was sent from F. Along with that, you have added a lot of your own internal network, which A may not be interested in learning. So, what is the solution? Do not redistribute, not recommended. Instead, run IBGP. So if I run IBGP between E and B, route given by F to E will be carried by the BGP itself and delivered to B. No need of OSPF to carry it. It will be delivered to B because it's a TCP protocol. It can directly give a copy of the update to B, and B will give to A. I'm going to do and show you this. Alright. So 1111, which is in Autonomous System 10, should be distributed by the middle autonomous system, which is Autonomous System 20, to the right hand side autonomous system router 6, which is in Autonomous System 30. This is the idea. We want route 6.6.6.6 to be available in router 1's routing table. Likewise, 1111 to be available in router 6 routing table. For that, we are going to have eBGP between router 5 and 6, between router 1 and 2. As we spoke earlier, we will have, this is OSPF, area 0, the entire autonomous system is running IGP. On all this router we have OSPF, and we are going to form IBGP between router 2 and 5 to get the routes from 5, give to 2, get the routes from 2, give to 5, so that 5 can give to 6 and 2 can give to 1. This is the idea. You may ask question if you don't have clarity on what we are speaking.
It's pretty clear to me, sir.
Thank you.
I just noticed on the presentations, the autonomous system numbers always begin with 65,000. Does that really matter?
No, it's okay. In the lab environment, you can use any autonomous system number, but there is a private and public range of autonomous system number. But it's usually the ISP who provides you the autonomous system number. So we are going to strictly follow what they give. In the lab environment, you can have any number. Alright. As usual, we are going to have loopback interface on every router. For example, router 3 will have 3.3.3.3. Okay. So let me take a notepad. Configure the basic as I said, we will be having loopback interface on every router. Router 3 will have 3.3.3.3. Router 5 will have 5.5.5.5 on the loopback interface. So I'm beginning the configuration from router 1. Loopback 0, IP address 101.1. Interface, the interface names G1/0. Yep. I'm not running BGP now. I'll take it separately for you. The configuration on the command line, because this is the first time you may be doing this. Router 1, where are you? Here. The basic configuration on router 1 is over, and now this is for router 6. Router 6 configuration is also done. Next, I would like to go to router 5. Router 5 has also got loopback interface. Please understand, on router 5 I have to run OSPF because it's within the middle autonomous system. I'll say IP OSPF 1 area 0. But I'll not be running OSPF on the WAN facing interface. What is it? WAN facing interface. The interface that connects to router 6 is what? WAN facing, because it's connecting to another autonomous system. I should not run OSPF there. I'm not running. But I should run OSPF on the other two side of the router. One is F00, another one is F0/1. On F00, the IP address need to be 10.35.0.5. On F01, it should be 10.45.0.5. And we need to run OSPF on the inside interfaces, and it is done. So this we paste it on router 5. 165 is ready. Let's now move on to router 2. Router 2 also has got 3 interfaces. The loopback. Do you follow these things? Are you comfortable? No answer, which means not comfortable. I'm just giving IP address on the interface.
Sir, the interface subsequently.
No. This is gig 1/0.
Okay.
Arindram, are you comfortable with this, what I'm doing with the notepad?
Yes, sir.
Sam?
So that's it, son.
I didn't get you. It's okay. I don't know what you said. But try to understand. We are just giving IP address, that's all. Okay, this is for router 3. Router 3 do not have this interface. There is no WAN interface, so I removed it. And all other interfaces should run OSPF. Router 3. Now next is router 4. You see it is F00 here. 24 and 45 is F01. Okay, router 4 is also done. So what I'm expecting is the Ospf convergence. I should see router 2 should have 2 routes to 5555. Show IP route Ospf. I see only one route to reach loopback of router 5, which is a router via the router 3, which means there is some issue between router 4 and router 5. Let me check why. Router 4, how many neighbors? I should see 2 neighbors, but I see only, no, I see 2 neighbors. Show IP route OSPF. I'm learning 5555 here. And why router 2 is not showing that? Yeah, it shows now. 55555, you can go via router 4 as well as via router 3. Equal cost. Equal cost. What is the 110? It's OSPF administrative distance. What is the 3? Is the metric. That is the cost. Fine, we got OSPF. First, I'm going to show you forming an IBGP neighbor between router 2 and router 5. Please focus. I'm going to form an IBGP neighbor between router 2 and 5. What is the autonomous system number in which router 2 and 5 located? What is the autonomous system number? Why you take so long? It's right there in front of you. AS20. So this is a command. Router BGP 20. Next. I told you BGP is a TCP based protocol. We need to provide the neighbor information. It's a TCP based protocol, so we need to provide the neighbor information. I'm trying to form neighbor between 2 and 5. What address should I give? Should I give this interface address as a neighbor in router 2? Should I give router 5 this interface address or this interface address, or a loopback interface address? We also have got 5.5.5.5 here. Which one should I give? Sam. When I configure neighbor on router 2, saying router 5 is a neighbor, which one address should I give? Should I give the loopback interface of router 5, or F00 of router 5, or F01 of router 5?
Would it be none?
Not none. No.
Meaning to just configure the command ladder?
No. We have to provide an IP address of router 5 as a neighbor in router 2. Whenever we got redundant path like this, whenever we have a redundant path like this is one path to router 5, this is another path to router 5. Whenever we got redundant paths to router 5, to the remote neighbor, we always need to use the loopback interface address. You understood? Why? The loopback interface can be reached on both the direction. You can reach this way as well as this way. So if this link goes down, you don't need to worry, because the loopback interface address is still available via this interface. But if you will give physical interface address on router 2, if I will give this interface address, if this link goes down, then I lose the neighbor. But when I give the loopback interface address, if any one path is available, my neighbor is going to be available for me. So I'm going to say my neighbor is 5.5.5.5. See, I'm not typing network command, I'm typing neighbor. Neighbor is 5.5.5.5. And neighbor belong to the autonomous system number 20. So though I use the command remote autonomous system, because of the remote word, you should not get confused. What matters is the number. This router also belong to 20. Neighbor also belong to 20. Which means they are IBGP. If this is two different number, then they are EBGP, correct? If the neighbor is in different number, then it means EBGP. When this router and the neighbor autonomous system is same, we call it as IBGP. Fine. Likewise, I need to go to router 5 now and say router BGP 20 neighbor 1.1.1.1. Sorry, not 1.1.1. What should I say? Tell me, what should I say? I'm in router 5. I want to form neighbor with router 2. What address should I give?
Neighbor 2.2.2.
2.2.2.2.
Remote AS.
Remote AS is also same number 20. It's IBGP. Okay. But they won't form neighbor. Even though I have configured neighbor correctly and autonomous correctly, they won't form neighbor. The problem is, you see, we have said neighbor is 2. this router is sending the packet to 22222 with some source address. It may be this source address or this source address. It is going with one of the source address because if it is going via this way, it will take this address as a source, which is not matching in the neighbor statement of router 2. The neighbor statement of router 2, what is the neighbor address? 5.5.5.5. So in order to match that, what we need to say is, we need to say, whenever you speak to neighbor 2.2.2.2, you need to use all the source of the packet should be updated using the loopback 0 IP address. So it takes 55555 and speaks to 22222. See, the neighbor has come up. Also do that same on router 2. Neighbor 5.5.5.5 update source loopback 0. See, if you do on one side, the other side will come up like this, but it is recommended to do on both sides. Update source loopback 0 we use because we want to send all the packets sourcing from loopback, because our loopback address is what configured as neighbor address in the remote router. Understand this very well. Fine. We have finished configuring IBGP.
So this update source loopback 0, so that is needed on the both sides, right, sir?
Yeah, it should be written on both sides. But if you do it on one side, the neighbor will come, but don't be satisfied with that. Go and configure on both sides.
Okay.
Next, we are going to form eBGP between these two routers, 5 and 6. Router BGP 30. Sorry, not 5. On router 5, I need to say router BGP 20. So you cannot run more than one BGP. It says already 20 is running. That's true. Router 5 is in 20. So 30 that I was trying to type is wrong. Anyway, it didn't accept. Router BGP 20. I'm going to say I got a neighbor. What is the neighbor's address? Router 6 neighbor's address? 56.56.56.6. Don't use the loopback interface because you don't have redundant paths. We don't have redundant path between 5 and 6. 56.56.56.56. Remote AS is 30. Likewise, go to router 6. Router BGP 30. Neighbor is 56.56.56.5. Remote AS is 20. You see, this number 30 and this number 20 is not same. That makes this router 6 to understand this neighbor is an eBGP neighbor. When the number is same, the neighbor is IBGP. Okay. We have finished configuring eBGP. Look at this. The neighbor has come up. Likewise, let us also form neighbor between router 1 and router 2.
Sir, here update source is not needed because this is directly connected.
Yes. We are not using loopback interface. Neighbor 12.12.12.2. Remote AS is 20. Likewise on R2, neighbor 12.12.12.1, remote AS is 10. I'm expecting a neighbor. Yeah, it's come up. Now, see, we got eBGP neighbor, we got IBGP neighbor. What next we need to check is, are we advertising any routes? No. So far, no. On router 6, show IP interface brief. I got a Lubeck address and I want to advertise this to router 1. So first let me check show IP BGP summary. This is the command which will say whether the BGP is up or not. Yes, it is up for last 1 minute and 37 seconds. But so far no network is learned, no prefix is learned from that neighbor. Next command is show IP BGP. I cut the summary. This will show whether we are learning something or whether we are advertising something. We neither advertise nor learn. Let us advertise. Router BGP 30. Router BGP 30. Network 6.6.6.6 mask. This is the syntax. You have to type mask, keyword mask, and match the exact mask that is on the interface. Fine. See, I'm not using neighbor command here. I'm using network command here. To advertise, you should use network command. To form neighbor, you should use neighbor command. Now, if I go and type that same command back, show IP BGP, you should see this. It says 6.6.6.6 is locally advertised. That's why there is no next hop. Locally advertised. Likewise, let us do it on R1. R1, pay attention. Router BGP 10, network 1.1.1.1, remote AS, network 1.1.1, mask 255.255.255. Boom. Now I should be seeing this. Show IP BGP. Yeah, this also says I'm advertising this. But what I'm not learning is 6.6.6.6. I'm not learning 6.6.6.6.
Sir, one question, sir. Sir, why we don't see that next hop? I know that it's a locally originated routes, but basically, sir, why next hop is not there, sir? Because next hop, it has to advertise also. You need some hop, some gateway. Might be I'm wrong. My question is wrong, but it is my confusion.
See, when advertisement goes out of this router, that source address will become the next hop to router 2. Router 2 will be receiving packet from someone. No, that someone's address will become a next hop. Why should I put that one here? See, if I put router 1's address here and I am already in router 1, won't that be a confusion? That's why it says 0000. There is no next hop needed for this. There is no next hop needed for this because this belongs to me.
Okay.
But when router 2 receives, see how it receives. Let me show you on router 2. Show IP BGP. Router 2 learns saying it is coming from router 1. And here router 2 learns saying this is coming from router 6.
Okay. Okay.
Fine. Now, router 2 is not giving to router 1 that 6.6.6.6. I'm not learning 6.6.6. Likewise on router 6, I'm not learning 1.1.1.1, but that 1.1.1.1 is available on router 5. You see, let me show you. Show IP BGP. Here it is available, but it is not advertised to router 6. The reason is this next hop is not a reachable address for router 5. So we need to make it reachable. How? I'm going to run OSPF only on this interface, router 2's and router 5's gig Ethernet. I'm not running OSPF on router 1 and 6. I'm not running OSPF on router 1 and 6, but I'm going to run OSPF on the WAN facing interface just for solving this issue. But there are various ways to solve this issue, which we'll be seeing in another class. Here I'm going to solve by typing IP OSPF 1 area 0. Likewise on router 5, alright. Now if you will go to router 1, you will see 6.6.6.6 coming. It will come in some time. Look at this. Router 1 has learned 6.6.6.6. Coming from where? Router 2. Router 2 is in which autonomous system? 20. Autonomous system 20 learned it from where? 30. 30 is the place from where it originated. True or false? See the picture and tell me.
Yes.
Yes. Autonomous system 30 is the place where 6.6.6.6 originated. Likewise, if you go to router 6, wait some time, you will be getting 1.1.1.1 soon. Router 2 is not properly configured with the OSPF. Okay, now you see, in router 6, I should be learning the route. Earlier we were not learning 11111, but now I learn it. I learn it and it shows the AS path. That's why it is called as path vector routing protocol. It shows the autonomous system path. Right? So this may be a tough lab for you. But if you try doing this by watching this video, passing it wherever you need, you will learn a lot. Do this lab and then come next class. Do this lab.
Sir, I have one question, sir. Sir, we have done OSPF, but we can run any kind of IGP protocol, right? Even we can run, we could have done it by static route.
Yeah, you can do it. Very well. You need route, that's all.
Okay.
Fine. See you in next class, but do the lab and then come with doubts. We'll fix it and then we'll proceed. Thank you.